Today we're going to cover both a few new data types that you haven't seen before, and then we're going to go into something called conditionals, which is going to give us a way to do something like to take one of two alternative actions, such as if the user enters a bad gallons consumed when we're computing miles per gallon, we could actually alert the user to the fact that, for example, they input a number that was less than or equal to 0. So we're going to start with three new data types, which are characters, bools, and strings. And characters and strings are related, so we're going to discuss them together. So a character is a single character, whereas a string is 0 or more characters. And in C++, if we want to just have a variable represent a single character, we declare it as a char. And we use single apostrophes around the letter. Whereas if we want to declare something as a string, we declare the variable as a string, and when we assign a value to it, we put double quotes around the string of characters. And it's important to note that the string A is different from the character A. The string A has double quotes around it. A single character A has single quotes around it. This single character A could be assigned to a char variable, but not to a string variable. Similarly, this string could be assigned to a string variable, but not a char. And finally, I did say a string is 0 or more characters. We are allowed to have what's called an empty string, which is absolutely nothing between the double quotes. So here you see some sample declarations of char and string variables, and as I said, char variables start with char, string variables with string, and you assign to them just as you assigned to your number variables using assignment statements. You read into these variables using exactly the same syntax you used for reading into numbers, and you print their values using exactly the same syntax. So here I want to, first of all, I got the user ID and the gender of the person, and down here, and their grade, and down here I was printing it out. You can see here I print the value of user ID, here I print the value of sex, and here I print the value of grade, just as though I had printed the numbers earlier in the semester. And finally, you'll see some of this in the book now, so I'm just going to briefly mention it. With strings, you're allowed to use the plus operator, but it no longer means addition. Instead, it means concatenation. So for example, if I have this web address, and then I wanted to add to it the HTTP prefix, I could write this quote plus operation, which is really concatenation, and it will concatenate HTTP to the front of web address. So the outcome here would be HTTP colon www.eecs. I'm not going to write out the rest of it, .utk.edu/tilde/bvz. And when we want to include strings in our program, you actually need to place the #include string statement right after IOString. You'll find that it doesn't, that Code Light is permissive about it, and even if you don't include this statement, it works. But not all C++ compilers are that accepting. So it's a good idea when you declare string variables that you have this include string. Nothing needs to be done for characters and bools. Basically, or for characters, we haven't talked about bools yet. We call numbers and chars something called built-in data types. They're the basic types that C++ understands. It turns out that string is built up from chars, and so it's considered an aggregate data type. It's a collection of chars, and therefore it's not part of the underlying language, and instead the definition for a string is stored in a library. Hence, you have to include the string library in order for strings to work. The third type we're going to talk about are Boolean types, and you'll see more about them when we get into conditionals. But bools have two values, true or false, or in effect binary, and they come from logic. So for example, if I could declare here, I've got two variables named manager and Ismail, and manager is actually undefined. I haven't given it a default value. Ismail, I have given a default value of false. And I can assign values to bools just as with any other variables. Again, just like numbers have the values 0, 1, 2, 3, 4, 5, there are two values for bools, true or false. Unfortunately, bools are a new addition to C++, and you'll recall that C++ evolved from C. The original C language did not have the bool data type. Instead, it represented them as integers, and specifically it used 0 to represent false and 1 to represent the value true. And so C++ will actually output a bool. When you output it via cout, it will output the bool as either a 0 if it's false or a 1 if it's true, which can be a little disconcerting. And similarly, when you provide input, you can't input as false or true. You have to input as 0 or 1. Okay, and if you give any other value than either a 0 or 1, that might confuse your program and it may not terminate properly. So just as an example, here I have a very simple program. It just declares manager as a bool, then it outputs a prompt, and as to whether Brad is a manager, reads it in, and then prints out manager. So I'm going to show you that you need to input as integers. Now, I'll build it and run it. So I'll say, no, Brad's not a manager, 0, and it printed out 0. So let's say I instead tried to do it as a literal. Let's say I said, okay, is Brad a manager? Yes. And it output 0. That's not what I meant. So you really do have to input as 0 or 1, or things may not work the way you expect them to. Okay, and this screen just shows exactly what I said a moment ago when I demoed it for you with Code Light. Okay, so that's a quick overview of the character, string, and bool data types. You'll be seeing them through the rest of the semester, so this was just meant as a brief introduction to them. Next, we're going to talk about one of the very basic constructs in C++ and in any programming language, and that's the if-then-else statement. So as a motivating problem, let's say I want to assign a passing grade to a student if they have a score of 70 or higher on an exam and a failing grade otherwise. How can I accomplish this task? Well, if you think about it, you don't have the tools right now, given what we've already taught you, to do that in a program. So C++ has a construct for it called a conditional statement. And you can see down at the bottom of this slide that I have said if score is greater than or equals 70, then grade equals capital P, else grade equals F. Now, if I asked you what are the types of these two variables, you should be able to guess by looking at the values. You should be able to guess that score is an int, and you should be able to guess that grade was declared as a char, because when I assigned a value to grade, I assigned a char value. So the if statement, the if right here, what happens is it evaluates the expression. If it's true, then it evaluates the statement immediately after the if. And if it's false, then it evaluates the statement after the else. So for example, if score was 85, then the statement score greater than or equal to 70 is true, and we evaluate or we assign P to grade. But if score was 55, then that statement is false, and we would execute the else branch. So basically, if something is true, execute what's after the if. If it's false, execute the statement after the else. Sometimes it helps to view it pictorially in if-then-else. So this flowchart shows the quote flow of control. So the diamond is the decision box, and we ask is score greater than or equals 70, and if it's true, it flows this way. If it's false, it flows that way, and then whatever the result, it comes back together and we execute whatever condition comes after this conditional. So there's a number of ways that you can apply if-then-else statements. First of all, you do not have to use an else. Sometimes you're only looking to correct something. Here are two cases. In the first case, I want to get the absolute value of a number. That is, I want to make sure that the number is positive. So if the number comes in as negative, like -5, I want to convert it to a positive 5. And that's what this statement does. Since -5 is less than 0, the expression is true, and I evaluate this statement right here. You haven't actually seen this negative sign. We didn't do it with the arithmetic, but what it says is just like you expect from math classes, it inverts the number. So in this case, the -5 gets converted to a 5. By contrast, if number is 10, then 10 is not less than 0, and so this statement is false, and we do not execute this statement right here, and number stays as 10. And finally, remember, I said it's always good to consider the boundary cases. Here, 0 is a boundary case. So 0 is not less than 0, so this expression is false, and this statement is not evaluated, and 0 remains 0. So you can see that basically this if statement just inverts a number. Similarly, down here, this if statement ensures that a number is always odd. So if we come in with an odd number like 5, okay, how can we determine if a number is odd? Well, one way, a very convenient way, is with the remainder operator. We can divide it by 2. If it's an odd number, the remainder will be 1. If it's even, the remainder will be 0. So in effect, what this statement right here says is if the number is even, add 1 to it, because if the number is even, its remainder will be 0. So if number is 5, the remainder of 5 divided by 2 is 1, and this statement does not get executed, and we still have 5. If instead the number is 10, well then when we come in, 10 mod 2, or 10 divided by 2, its remainder is in fact 0, so we end up executing this statement and adding 1 to number, giving it 11. And finally, minus 8, you can divide negative numbers by 2. It still gives you a remainder of 0. Quotient is minus 4, remainder is 0, so the statement is true. And we add 1 to the number, thus getting minus 7. So a single if statement can be used, as in this case, sometimes you just want to correct something if it doesn't satisfy a certain condition. But if it already satisfies the condition, there's no reason to do anything to it, so you just use a single if. And here's the depiction of it as a flowchart. You can see that the false branch does nothing. Okay, well, the if-then-else worked really well for a passing pass-fail, but what if I wanted to do something a little more sophisticated? What if I want to assign letter grades so that the score of 90 to 100 is an A, 80 to 90 is a B, 70 to 80 is a C, and anything less than 70 is an F? Well, now it's more difficult. I don't have an either or case, I have 4 cases. I can handle that with what are called multiple if-else statements. So if you look at this code, it starts by saying if grade is greater than or equal to 90. Now I know I said if it was 90 to 100. For the time being, we'll assume that any grade greater than or equal to 90 deserves a final grade of A. Okay? So if that's not true, what we've done is divided our cases into 2. The case where grade is greater than or equal to 90, and the case where it's not. So the case where it's not is this entire statement down here. And you'll notice that we started right after the else, we put another if. So we're asking if now the grade is greater than or equal to 80, then we will give it a final grade of B. And you may say, well, wait, what if grade was 95? Well, if it was 95, it was handled right here, and we never got down to this else statement. So if you kind of want to look at how things are going with a flowchart, we're first of all asking if grade, which I'm going to denote using G, is greater than or equal to 90. If the answer is true, it's an A. If it's false, we go over here and we ask the question. So we know it's less than 90. So the next question we're asking, is it greater than or equal to 80? And if the answer is true, then we're going to assign it B. Otherwise, if it's false, as you can see, we go down and we check to see if the grade is greater than or equal to 70. So we're basically still having this idea of 2 cases, but once we find that we're into the second or false case, we're then further subdividing that into 2 more cases. Okay, so over here, you kind of can see the result that if the grade is 95, it certainly assigns a grade of A. Now I always say let's play computer, so let's do that. Okay, so let's say that it's 55. Well, we ask, is it greater than or equal to 90? No. Else, is it greater than or equal to 80? No. Else, is it greater than or equal to 70? No. Therefore, it's an F. And you should be able to apply the same logic to get the B. For grade equals, if grade is 80, you should be able to figure out why the final grade will be assigned a value of B. And you may wonder, why are we using the greater than sign followed by equal to determine if grade is greater than equal 90. You might wonder, well, why didn't you just do it like this? Because after all, that's what we do in the math classes. Well, I challenge you to find this greater than or equal key on your keyboard. It doesn't exist. So C++, the designers had to come up with a way to denote greater than equal, and the way they decided to do it was to put the greater than sign first, followed by an equal sign. Okay, so here's that depiction of that multiple if-else, and we already went over it. I'll let you study it more on your own time. Okay, so that was multiple if-else. There's some other problems that I could give you that we still haven't quite covered. So you often are challenged for both a user ID and a password when you try to log on to a site. And basically, let's say this is what I want to do. I want to first check the user ID. So the user's given me both a user ID and a password. I'm in possession of both pieces of information. So the first thing I want to do is check the user ID. And if it succeeds, then I want to check the password. If it fails, I just want to print an error message saying you have a bad user ID. I don't want to even look at the password. There's no reason to, because the user ID wasn't even correct. But if it succeeds, then I will check the password. So if the password succeeds, I want to print a welcoming message, welcome back, Brad. But if the password fails, then I want to print an error message about a bad password. Turns out that the two examples I've given you with simple if-else or multiple if-else really wouldn't work in this situation. Okay, I could say, I write some what I call pseudocode if, and I'll just say user ID is okay, because again it's pseudocode. Okay, what am I supposed to do? Okay, well, it's not print a welcoming message. I want another if statement. So you're not really sure what to do here. If it's an else, if the user ID is not okay, you know what to do. It's this case right here. We print an error message. So kind of the question is, if user ID is okay, if it's true, how do I handle this part here? That's the question mark. Okay, well, it's something that we call a nested if-else statement. We're going to nest a second if-else within one of the if-else branches. So we often talk about each of these two elements as being a branch, or sometimes you'll hear me refer to it as an arm, a branch of an if-then-else or an arm of the if-then-else. So in this case, what I'm doing is I'm embedding a second if-then-else into the true logic for this if statement. So if the user ID is equal to BVZ, then I'm having a second conditional that asks if the password is equal to CS102, then I print a welcoming message, else I print a message that it was the wrong password. And you'll see that there are curly braces here. I need to use curly braces when I have either a complicated statement or complex statement like this one, or a compound statement. Before, I just had simple arithmetic statements or assignment statements. So here, each action was simply an assignment statement. This is more complicated. I have a conditional, and so when I do that, when I have what are called compound statements, I have to put them in curly braces. Same thing down here with my else. You'll notice I started it with curly braces, and that's because I had two print statements here. And it's the same idea. A compound statement is something that has, think of a compound statement as one that has as a multiple or a group of multiple statements. Okay, each of the two branches you can see have multiple statements, therefore you have to use curly braces. The other thing to recognize is notice I use two equal signs here. Remember that the single equal sign is reserved by C++ for assignment. So if I simply said if user ID equals BVZ, I would not get the outcome I intended if, let's say, user ID was Nils, who is my brother. Okay? What would happen is it would first assign BVZ to user ID and wipe out Nils, replacing it with BVZ. And then it just so happens it would say, well, yes, this is true, and it would go on and check the password. So don't use a single assignment or a single equal sign when you're comparing two quantities for equality. Use the double equal sign. Okay, so here's three cases. We'll go over this also in class, which is why you see clicker here. I'll cross that out right now. So let's just see what we would do with each of these three values. So we start with the user ID of BVZ, and it is going to be equal to BVZ, so we're going to come into this statement right here because the expression is true. However, the password is UTK. That is not equal to CS102, and therefore our output would be wrong password. In the second case, with the user ID equal to Nils, you can see that this statement immediately fails. It's false. So we come down to the else clause, and we end up printing wrong user ID. Try using BVZ next time. And finally, this last case, we have user ID is BVZ, so this statement right here is true. We now come and execute this conditional. The password CS102 causes this expression to be true, and we print out welcome back Brad. Okay, so here's the depiction of a nested if. And you can see that the false statement, very simple. We said the user ID was no good. On the true side, we went to another test to check whether the password was equal to 1 or 2 or not. And if it was, we printed welcome back, Brad. If it wasn't, we did wrong password. Okay, we just covered compound statements. They are a group of two or more statements. So here, this is considered, well, certainly 5. So we had to put curly braces around the code. So here, we're calculating the balance due on a ticket and saying if the number of overdue days is greater than 30, there's a 5% fine tacked on. So that's what's happening. You should be able to read through this code and figure out that it's adding a 5% fine. And again, this is just the flowchart depiction of that compound statement. Okay, now just a quick kind of intermezzo here, which is that the const keyword, which we're going to see next, allows us to declare that a variable is read-only. That is, you can't assign a value to it. So if you put the keyword const in front of a variable declaration, it means that you have to, that it's assigned a value right here, which is what we do. That value cannot be changed. And the advantage of using a constant as opposed to a hard-coded value is that the program is more readable and it's more maintainable. You'll see that right here in our next if-else, where we're determining, let's say we're Amazon and we want to determine if a person gets free shipping or not. They get free shipping if their order amount is greater than or equal to $25. And rather than hard coding the shipping charges, which is 0, it's free if it's greater than 25, or it's $5.50 if it's less than, we put them into constants, and the same thing with the sales tax. We're setting it to 6% or 0.06. So down here you see if the order amount is greater than or equal to 25, we set the shipping to be whatever the free shipping is, multiply the order amount by the sales tax rate, and then increment it by the sales tax rate. Similarly, if it's less than 25, we set shipping to regular shipping. Again, set the sales tax to be the order amount times sales tax, and then combine the shipping, the sales tax, and the order amount. And notice that if we wanted to change the sales tax rate, we only have to change it once, which is right here, rather than twice, which would be here and here. And in general, we might use these constants in multiple places in the program. It's highly desirable that we be able to just change one line in our program rather than potentially looking through millions of lines of code, which happens in real systems, looking for all the places where we might have had a sales tax of 6%. Okay, I'll let you work out these what the values of these variables are as an exercise. We'll probably do it in class, in fact. Okay, and just kind of wrapping up, if we have a Boolean variable, then we don't even have to compare, because a Boolean variable already evaluates to true or false. So we might have a declaration bool Facebook member, and now we could ask, there would be some processing here because we'd have to assign a value to Facebook member. We could ask if Facebook member, and Facebook member evaluates to either true or false. So if it evaluates to true, we're going to assign 5 to coupon and increment Facebook count. Otherwise, we're going to set the coupon to be 2. Okay, so for example here, if Facebook member is true and Facebook count is 5, then when we evaluate this if statement, since Facebook member is true, we come into this part, execute coupon equals 5, so coupon gets set to 5. Facebook count gets incremented. Remember, the plus plus is an idiom for incrementing a value or a variable by 1. So its value of Facebook count was 5. It's now going to be 6. Okay, whereas here, in this case, Facebook member is false, so we end up coming down here, and coupon only gets set to 2 in this case. And in that case, Facebook count, which is 23, remains unchanged. Okay, so just that review of if-else is that if it's a single statement, a simple statement, we can say if condition, then if it's true, we execute the true statement. If it's false, we do else and the false statement. Or we can have multiple statements, in which case we enclose them between curly braces. Next time we're going to talk about Boolean expressions, which is going to allow this condition to be a bit more complicated, and another way called switch statements to express if-then-else's.